Hey students, this is the video notes for section 10.1 and 10.2, area circumference of a circle, finding the area of a sector and arc length. This goes with this because area of a sector is dealing with the area of a circle. It's part of a circle. And then an arc length is talking about the circumference. And if you were to take part of the circumference and lay it out and measure it, what would it measure? We use a formula to find the arc length. So we're going to fly right through these notes and do both of these together. So you are required to know the formulas. Area of a circle is pi r squared. R is the radius. Your pi key on these calculators is right here. Okay, a lot of problems will ask us to leave pi in the answer, but then a lot of them will ask us to give a decimal. If it asks you to give a decimal, your pi key will throw that decimal in there because pi we know is 3.1459265. Continues on forever without repeating. But we'll probably round to 2 decimal places. Then on your graphing calculators, pi is a little bit harder to get to. It's a second function. So second function key, second rooftop, brings up the pi. Okay. We don't just use 3.14, we actually use our calculator button because it gives us more of an exact answer. It's not going to be that big of a deal, but in a real world situation, that 100th or 1000th of a decimal place may make a difference. Okay, I'm only going to do one of these top problems, then we're going to jump to the other problems. So for this one, just to show you area, so I'm not following these directions. Area is pi r squared. The more you write it, the more you're going to know it. So it's going to be pi times my radius is 12. You've learned what a radius is. You've learned what a diameter is. And so we are going to get decimal answers for these. And it doesn't matter if you put the pi in first or the number first. So I know it's 144. You could put 12 squared if you want. And then you just hit the pi key and then hit enter. It knows you're multiplying when you put those together. So my area is 452.39. And then we are putting our units. This is meters squared. Area is squared. Circumference is like perimeter. Okay, circumference is like perimeter. It's the measurement all the way around. And so the circumference formula, I like pi times diameter. If you cut the diameter in half, you're going to get the radius. On this worksheet, I tend to use this formula, but then guess what? When we get to this formula or this worksheet, I tend to use 2 pi r. Okay, so it doesn't matter which formula you use, you just need to know the difference between a diameter and a radius. So pi times diameter, this is going to be pi times 18. And we get 56.55. 56.55. Circumference is like perimeter, it's not squared. Area is squared, circumference is not. Okay, so we're just going to go down to the bottom and we're going to focus on looking at some word problems. All right, so the key to the word problems is knowing what you're given, use the formula that they ask you to start with, and find what they're asking you to end up with. So this one says find the diameter, so I'm going to end with D, of a circle with a circumference of 65.97. They gave us circumference, so we start with circumference. Circumference equals pi times diameter. I always start by writing a formula. And then I'm going to put in the pieces. I know that 65.97 is my C. To get the diameter by itself, all I have to do is divide by pi. Pi is just a number. And so I'm going to put in my calculator 65.97 divided by pi. Do not use 3.14, use your pi key. And the person who made this worksheet made these numbers come out really nice. We're going to put 21. So my diameter is 21. From that, actually 21 meters. From that, I could say what is the area. I could figure out the area. I could also say what is the radius. So just given one piece, I can find diameter, radius, and area off of the circumference. Okay, so would you please try number 10? And please, 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 please don't be tricked. It is asking for the radius. So you're going to end up with diameter, and you're going to take it and tell me what the radius is. Go ahead and do number 10. Okay, so I'm using the circumference formula because that's what they gave me to start with. And I put the 21.99. When I worked that out, it gave me 6.9998. And I know that's going to be a 7. Honestly, the person who made this worksheet did a great job at making those numbers come out. The radius is half of the diameter, so 3.5. Okay, so if they leave the pi in the problem, it's actually a little bit easier. So they gave us a circumference and they want to find the radius. So circumference equals pi times diameter, and 35 pi equals pi times diameter. The reason this is easier is because there's no need to pick up your calculator. My diameter is 35. And then the radius is going to be half of that. 35 divided by 2 is what, 17.5? Yeah. So the radius is 17.5 yards. Okay. Here we go. Find the radius of a circle with an area of 380.13 square inches. So we're going to start with the area formula. Area equals pi r squared. It's going to be the same steps, but it's going to have an extra step in there. How do you undo a square? You square root. So we're going to finish by taking the square root. All right, my area is 380.13. So what we're going to do is we're going to divide by pi first. 380.13 divided by pi. What is that? 121. And then we're going to take the square root. So r equals 11 inches. R equals 11 inches. Okay, you go ahead and do number 13 for me. All right, I hope you didn't get tricked. So it did end up with the radius, but they wanted the diameter. So we're going to double that radius to get the diameter. So they gave us the area. So I put that into the area formula. I divide by pi. It was 195.9999. So that's 196. And then square root that and you get 14. Double it to get the diameter. Okay, and then show you one with the pi in it. And then we're going to move on to one of these problems down here. So this one says find the diameter if they give us the area. So 90.25 pi equals pi r squared. Again, when they give you pi in the problem, makes life a little bit easier because all you're doing is you're taking the square root. Second square root of 90.25, and we get 9.5. So that radius is 9.5. What is the diameter? 9.5 times 2 is 9.5 times 2 is 19. So it's 19 meters. Okay, so that should be pretty easy for you. And then just one of these problems, let's start with the circumference and end up with the area. We'll do number 17. And then I'm going to have you start with the area, end up with circumference on this one. Okay, so number 17, we're starting with the circumference of a circle with an area. No, I'm sorry, we're ending with that. We are starting with the area formula because that's what they gave us, and we're ending with the circumference. So area equals pi r squared. 113.1 equals pi r squared. We're going to divide by pi first. Divided by pi. And see how nice that came out. 36 equals r squared, so r equals 6. And then circumference is, since I have radius, see, that's when you would use the radius formula, or pi times diameter. You could use 12. It's the same thing. And so the circumference is 2 times pi times 6. So 12 pi, 37.70. 37.70. And that is inches, not squared. Okay, you do number 18 for me, please. You are starting with the circumference formula and you are ending with the area. Go ahead and do number 18, please. All right, so I started with the circumference formula and I divided by pi. It gave me 42.0000 something. And then I cut that in half and I got my radius is 21. So then the area formula, 21 squared, pi 21 squared, gives us 1385.44 meters squared. Shouldn't be any questions about those problems. Okay, go to the next worksheet. Okay, so we're going to review our circle part names real quick, and then we're going to talk about the angle measures that we need to know for the next page. So in this picture here, this is the center. The way we name a circle is we put a circle with a dot in it with a T. That's just the notation. It's not anything fancy. You will see it written in textbooks like that, circle T, or you can write out CIRCLE-T. But that is the center of the circle. A circle is 360 degrees, we know. This is a radius. This is a radius. This is a radius. Okay, so you know what a radius is. The diameter goes from here to here. Okay, so CN is the diameter. So definition of a radius is a segment that has an endpoint at the center and an endpoint on the circle. Diameter is a segment that has both endpoints on the circle and goes through the center of the circle. Okay, because this right here has endpoints on the circle. This is called a chord. All right, a chord cuts, kind of chops the circle down. Chord chops, it does not have arrows on it. This is a secant. A secant slices right through that circle. So this is a secant. And then this is a tangent. A tangent touches the circle. Anything that is tangent to anything else means that it touches at one point, not to be confused with our trig. Tangent has nothing to do with that. So those are all of the parts of the circle. And I do want to bring it to your attention that a secant has a chord in it. In WZ with WZ with a segment above it is a chord. And then WZ with a line above it is a secant, S-E-C-A-N-T. So just know that the definition of a segment is part of a line. So because a secant is a line, a chord can be inside that secant as the segment. Okay, so it all matters about the notation. All right, in our circle, with the degrees. So a circle is 360 degrees. Half of a circle is 180. If you have a diameter, that cuts the circle in half. The central angle is going to be equal to the arc measure. So when you see a 70 here, you also see a 70 here, whether it's written there or not. So what is this? 7, 8, 9, 10, 11. That's 110 together. So that means this angle here has to be 70 as well. Okay, and this arc would be 70, and then this arc would be 40. Okay, we have a 90 right here, so I know that this is 90 degrees, and this arc is 90 degrees. And then this is a vertical angle, so we have 40 degrees here, 40-degree arc, and then 9, 10, 11, 12, 13, 130, so what, 50 degrees right here, and a 50-degree arc. Let's talk about the minor major. A minor arc is an arc that is less than 180 degrees. So PB with an arc above it is minor. Even PS is minor. Okay. A major arc is an arc that's bigger than 180 degrees. So what I do when I ask you to name a major arc is pick somewhere, go where you think 180 is, and then find the next letter. So if I was going to start with N, and a major arc has to have 3 letters. If I was going to start with N and end with T, I would have to have any letter from here to here with one of these 3 letters in the middle. So I could pick P, B, or S. I'm just going to put S. Okay, so there's lots of ways to name a major arc. All right, lots of ways to name a major arc. You just have to make sure you have 3 letters. The reason you have to have 3 letters is because if I said NT, well, if I go this way, NT is a minor arc this way. NT this way is a major arc. To show it's major, you have to have the 3 letters. A semicircle is half of a circle. And it's kind of riding the fence. You can use 2 letters. So PT is a semicircle because it doesn't matter whether I go PT this way or I go PT this way. I'm going to see that it's a semicircle. Or I can use 3 letters like PBT could also be a semicircle. Okay, so that's all the parts of what we need to know. Now let's talk about area of a sector and area of an arc length. So if, hold on just a second. It's always fun when the lights go out on you. So the formulas, if you know the area formula and the circumference formula, all you're doing for like, this is a sector. So a sector, if you think of this as a pizza, a sector is a piece of pizza. It has area. So what you're doing is you're finding a fraction of the whole pizza. Well, the whole pizza is 360 degrees. So all you're doing is you're getting that fraction